All right. After you have picked an appropriate solvent to do recrystallization, we're going to move on to the next step called dissolving. Okay. I'll go back to the diagram right here. So every time when you do recrystallization, usually involve two steps. Number one is dissolving and then crystallizing, which we're going to talk about later. Now, number two right here. So we're going to talk about dissolving. Okay. You're going to take the solvent that you just picked, put your compounds with the impurities in there. It's a mixer. Put that in that solvent, and then you're gonna dissolve everything. All right. But the tricky part is you're gonna use just the minimum amount of hot solvent. Say one more time. We're gonna use the minimum amount of hot solvent. Two words in here: minimal amount, and then hot solvent. Why minimum amount of solvent though? One thing about this, if you use way too much solvent, your compound, of course, it's a good thing. Dissolving is easy, right? Everything will get into the solution, but those everything will get to the solution and stay there forever. You can't make it come back to be solid, right? Because there's too high solubility. Okay, so you have to just get just right amount. How? That's a tricky part, but I'm gonna tell you later. Okay, now so minimum amount of solvent and hot solvent. Why hot solvent though? Mm, let's think about it. All right. Let's say if you want to dissolve, let's say sugar in your hot coffee, just add sugar in your hot coffee. Okay. Which coffee dissolve the sugar better? Cold coffee or hot coffee? Of course, it's hot coffee, right? Because the hot solvent dissolve compounds better, have higher solubility. Okay. And if the solvent is hot, it means that you don't need to use a lot of solvent. Remember the minimum amount of solvent? Yeah, so hot solvent help you prevent you to use too much amount of solvent. Okay. All right, look at the animation right here. All right, I'm gonna run this two times. All right, so first time I want you to look just right here in this Erlenmeyer flask. Okay, I'm gonna talk about the solubility meter in a bit, but just ignore them for now. Now just look at right here. All right. So basically, you're gonna take the solvent you just picked, drop into there, just dissolve your compound, your impurity, just dissolve in there, and of course, just keep adding a little and a little. Not everything gonna dissolve yet. Right? Just keep adding just a little. Okay, not too much yet. And remember, what we try to do again, we try to dissolve everything, your compound impurity, with the minimum amount of hot solvent. So just add a little at the beginning, not everything gonna dissolve. Okay. And you guys know solvent has the highest solubility at its boiling point. So we're gonna raise the temperature up, put this guy on hot plate. Okay. And then heat it up, and until it goes to the boiling point. Hopefully all impurities, compounds, everything get to the solution. If you get to that point, you're gonna see your solution as clear as water. Look like that. That's on the left side. That's not clear. This is clear, right? You can actually see it. Okay. All right. One more time. Now, here's a theory behind it. Go back right here. Okay. Before you do anything, now you have a mixture from the extraction, right? You have your compound. You have a mixture in it. Have a impurity in it. Now, I want you to look at the I made up the solubility meter. Doesn't show you the temperature. No, that's not temperature. It tells you the solubility. Okay. The rule is if the meter goes above soluble zone, now this meter goes up above the soluble zone, everything will be dissolved. Okay. Now think about this. How do you increase the solubility? How do you dissolve the compound basically? Okay. Well, there are two things. One, you can add more solvent. Right? Imagine try to dissolve sugar. Well, you add more coffee. Okay, so adding more coffee, adding more solution or solvent, you can increase the solubility. Now that's how you increase the solubility meter. That's another way to increase the solubility. What's the other way? I'll have you guess. The temperature, high solubility, low temperature, low solubility. Okay, so at the beginning, you're gonna dissolve your compound, use a minimum amount of hot solvent. So add just a little, not a lot yet. When you have add some of the solvent, of course, solubility goes up. Okay. Now, it doesn't go up above the soluble zone yet. So we're gonna heat it up to the boiling point, to its boiling point that has a high solubility. When the solution is boiling, the solubility go up maybe just a little bit more. If this go up, the meter go up above the soluble zone, everything will be dissolved. Okay, and you're gonna see clear solution, as clear as water. All right, just a little safety moment. So you might be familiar with if you have a pot of water, you add, like, you boil eggs, or you do something like this soup, whatever. If you heat it too much, it boil, and boil too much, it overflow. Okay, there's a little trick in cooking. You can put a wooden spoon or spatula on top of a pot with boiling water. Okay, this can make the bubble subsides. The reason is, well, if you think about it, I think you guys know water is polar and non-polar. Water molecules highly polar. Okay, the surface of the wooden spoon is non-polar, and when polar compound and non-polar compound get next to each other, what do? Well, they repel. Okay, so basically, the wooden spoon repel the bubble. Okay, but not just that though. Another reason is, well, if the wooden spoon just repel, oh, the water, the bubble can go on the side, right? But that's another reason. Imagine when hot substance like water is 100 degrees, okay, come into contact with a cold substance like wooden stick. Hot and cold get together, the surface start to break. Okay, it start to break, and the bubble has a really thin layer of water molecules stick to each other, like try to like keep that bubble stay not that stable. If you basically you just poke it with the cold wooden spoon and it just break right away. Okay, anyway, for the lab we don't have the wooden spoon for you, but we got either one of these, either boiling stick or the boiling stone. Okay, just put just one stick in there, or maybe just a couple of 2 3 boiling stone into your Erlenmeyer flask when you like dissolving your compound, and that's it. Just keep you safe. All right, so when we talk about on this video, well, how to dissolve your compound and everything impurity as well. All right, so we're gonna use the minimum amount of hot solvent, and we're gonna move on to the crystallizing step. Okay, all right, move on to the next video.